Alright guys, so in today's video, I'm going to be showing you exactly how to do a Gaussian elimination in Matlab, alright? So if you want to do a Gaussian elimination inside of Matlab, watch this video step by step and make sure you watch the video to the end because that's exactly what I'm going to be showing you, right? How to do a Gaussian elimination in Matlab, alright? So the first thing you want to do obviously is to come over to the Matlab website. As you can see, if you don't know how to convert to the Matlab website, just open a new tab. That's basically it, right? Then type in Matlab, click on it, the MathWorks website will come up. When you click on it, you should take it inside. You come to the top right and then click on where it says Matlab, right? Super simple. That's basically how to open it, and then the Matlab will actually open. Then you'll be given two options right here to install Matlab or open Matlab online. I'm going to go for open Matlab online simply because the installation is actually a very long process, but then it's still worth it at the end. Right, assuming you already have an account, click on it and it's actually going to open the Matlab online. Alright, so this should take maybe about 10 seconds to actually come up, take about 10 seconds to load, but basically that's actually how to open the Matlab. Right, so we are going to be able to figure out, we're going to try to do Gaussian elimination in Matlab. Alright, so now that it's actually open, let me just briefly explain what a Gaussian elimination is, right? So you just have a better idea of what we're about to do. So if we want to do a Gaussian elimination inside of Matlab, we should at least know what the Gaussian elimination is. Alright, so let me explain what a Gaussian elimination is. Right, so basically what it is that a Gaussian elimination is a method of solving systems of linear equations of the form a dot x equal to b, right? So basically this is actually what it is, right? It's just a method of solving systems of linear equations, right, of this form basically. All right, so what that simply means is that it works by transforming the augmented matrix, right, the augmented matrix into raw echelon form, all right, and then performing back substitutions to find the values of the unknown. And there are basic methods of just solving it inside of Matlab, right? So there are basic method, different methods, right? So the method one, which is what we're going to be using, that I know of, is using Matlab's inbuilt functions, right? So this is the easiest, using Matlab's inbuilt function, right? So we are solving the equation we're going to solve with this, right? So if you have this, right, the coefficient matrix A and vector B in the code represents this system of three equations. I'm going to explain what that means, but this is the equation we're going to try to solve. All right, these three equations we're going to try to solve inside of Matlab. So what we're going to do right now is, first thing we're going to do is we are actually just going to open up Matlab, which is what we already did. Right, open Matlab on your system. We'll solve a simple system of linear equation using the Gaussian elimination. All right, which is what we're going to do. Next thing you want to do is to click on the new script here, which is here. Let me this. You want to click on new script right here. It is super simple. I'll click on it right here, as you can see. So what we're going to do next, after you click on it, right, you get a blank editor windows, right? So the next thing you want to do is to type the following code, right? Paste this code, this exact code in the new script, right? I'll paste the code to perform the Gaussian elimination manually so you can see each step. Okay, so what I'm going to do is I'm just going to take this code right here. I'm actually going to copy it right here. Let me just take it this way right here. Right, this is the code I'm going to copy. So you let me know if I should leave the code in the description of this video. Right, you let me know if I should leave the code, but basically you can actually watch this video again. You can watch the video again the second time and then pause it so you can get the individual digits. Let me try and make it bold so you can see the code. Let's see. I'll make it bold and just increase it so you can actually see. Right, so this is the code we're actually going to be copying inside of Matlab. I'll take it and I'm going to paste it right here. So I'm just going to copy and paste it right here, and then I'm just going to click on enter right here. Right, so now that we've done this, we've pasted it, we want to come here and save it right here, and that's the next step. We'll just try and save it. So I'm going to save it this form. I'm going to save it like this. I'm going to call it the Gaussian elimination .m, right? Gaussian elimination. I'll just save it like this. So right, let's see. Boom. So this is what we saved it, right? So the next thing we're going to do is to run the program. Alright, so now you're going to come here and click on where it says run. This green button that says run, click on it right here. Right, so as you can see, this is what's going to happen. There are two things that are going to come up right here, as we said here. Right, so what's going to happen, you'll see two outputs in the command windows, right? Row echelon form, the transformed matrix, and two, the solution, the final answers for x, y, and z. Okay, so this is it. This is the row echelon form right here. This is it below, and then as you can see, we also have the solution here, which is 2, 3, and -1. All right, so basically that's it. So when I run it, as you saw, right, Matlab showed the row echelon form and the final solution vector, right? That's the result of the Gaussian elimination, right? That's the result of the Gaussian elimination. So basically that's it, right? But then there's also a shortcut method, which is actually an easy one, where you will just paste in this one right here. We type in this in a new line or new script, just type in this one right here, and then we run it. When we do run it right here, let me show you exactly. So this is actually a shorter version. It's a shortcut that you can actually do. So just take this right here, and then I'll just copy it right here and actually open a new script or a new line, and then run this right here. So let me open a new script. I'm going to explain in a moment, but then if I just paste it right here, right, and then once we've done that, we just run it, right, you will notice that Matlab prints out the same solution. Let's see, run this right here. We'll save it, I don't know, no, let's just call it untitled 2. It doesn't really matter, right? Let's just save it. Yeah, and boom, as you can see right here, this is actually the solution it gave us for the second one. As you can see, it gave us 2, 3, and -1, right? Remember the first one we did, the solution was 2, 3, and -1, right? So this is actually a shorter version. So if you want to look, if you're looking for a shortcut, right, a shorter method of actually doing it, like this is it, right? The / operator automatically performs the Gaussian elimination behind the scene. So this is the fastest way for large systems. All right, this is fastest way for large systems. Right, so that's how you perform a Gaussian elimination in Matlab, right? Manually, step by step, and using the inbuilt in shortcut, right? Using the inbuilt shortcut. So basically, this is how actually I do mine. As you can see, this is how I've got it. We used the first one, which was this long code right here. You can also take your time and copy it, this one. You can also take this short one, right, which is a, b, and then x equals to a /b. Alright guys, so also you should know that this is actually, if you don't know, this is actually the answer we got, right? X equal to 2, y equals to 3, and z equals to -1, right? Basically this is what this means, right? This is what this means right here. And then if you don't know what a is, right, inside of the equation, why did we add this a inside of the code, right? If you don't know what this is, maybe you're new to math, just know that a is the coefficient matrix, right? It contains all the numbers, right? A is the coefficient matrix, right? And then I'll give you an example of what I mean by coefficient. For example, if you have equations like this, 2x plus y equals to 8, and minus 3x plus 4y equal to 2, and then a is now equals to this 2 and 1, meaning this 2 here, and then 1 because there's an invisible 1 here that makes it y, invisible 1, and also this -3, which is this -3, and also 4, right? They are the coefficient matrix. That's what it means, okay? Whilst b is the constant, right? The constant on the right side, right, of the equation. So if you go to the equation, this equation, for example, 8 is a constant, which is b, and also 2 as well, right? So based on this, our initial equation that we're solving for, right? This is just an example I gave, but then based on this, our initial equation we're solving for. Let me take you back to the equation. So now you won't understand why it is so. So this is a is 2, a is also 1, and a is also -1. At the same time, a is also -3, a is also -1, a is also 2, a is also -2, 1 and then 2 as well, whilst b, which are the constant, 8 minus 11 and then minus 3, right? So that's how we got the a, b, and c in the formula, right? Because we used it in this our first formula right here. We also used it in the shortcut, our shortcut method formula right here. We also did this right here. So basically that's how we got the a and the b, so you'll not be confused, and that's how we're able to successfully use the Gaussian method, the Gaussian elimination method. So basically that's it for this video. Do well to like this video if you got any value from this video, and also subscribe. Make sure you subscribe to this channel, right? And yeah, with that being said guys, I will see you in the next video.